Welcome to the Drowsy Scientist, where the stars are quiet and curiosity never rushes. Here, we drift slowly through the cosmos, not to find answers quickly, but to rest in wonder and fall asleep inside the poetry of real science. You are floating, softly now, not in a spaceship but in your own imagination, a vessel as silent and light as breath. The stars above are no longer fixed. They drift like slow-moving fireflies. Space is dark, yes, but not empty. It holds secrets in its folds, gentle mysteries that shimmer at the edge of understanding. Tonight you drift backward, not through time exactly, but through meaning, through symmetry. For every you, perhaps an un-you. For every movement, an echo. And for every particle, a twin, reversed. This is the beginning of antimatter. The term feels heavy at first. It has the sound of science fiction, of glowing tubes and impossible explosions. But tonight, it is softer than that. Antimatter is not violent, not loud. It is a kind of balance, hidden inside the structure of the universe. Imagine a mirror held up to nature, so precise that it reflects not just shape, but behavior, charge, spin, mass, everything except presence. You begin with something familiar, matter, the stuff of stars and skin, apples and oceans, thoughts and thunder. Each bit of matter is made of particles, tiny, indivisible building blocks that hum at the heart of everything. Protons, neutrons, electrons, these names may flicker in your memory, like lullabies from a childhood science class. But for each of these particles, there exists another, not simply opposite, but inverted. The electron's mirror twin is the positron. Same mass, same spin, but a flip in electric charge. Positive where the electron is negative. If you place them close enough, they do something extraordinary. They disappear. Or rather, they transform into pure energy, a pulse of light. The matter and antimatter don't cancel. They release. It is one of the most beautiful transactions in all of physics. The annihilation is not an ending, but a transformation, a return. You imagine now a world where matter and antimatter existed in equal measure. You don't have to imagine too hard, because this world once was. In the beginning, before there were galaxies or gravity, before time stretched into a rhythm, the universe was hot, dense, and perfectly balanced. Matter and antimatter were born together, like twins holding hands. But something strange happened. The balance broke. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. Just one extra. Just enough. The rest? Gone, vanished in mutual embrace. Their collision became energy, and that energy became light. The light still echoes today. You see it in the background hum of the universe, the afterglow of birth. You are made of that one extra, the leftovers, a fluke perhaps, or a design hidden deeper than equations can yet describe. This idea settles over you like a warm blanket. You are the result of imbalance, of one more than zero, of something tipping the scale just slightly away from symmetry. It humbles you, it comforts you. The universe does not have to be perfect to be beautiful. It just has to be slightly off-center, like a lullaby sung just a little off-key. But what happened to the antimatter? It's a fair question, and tonight, questions are welcome companions. Antimatter did not vanish entirely. It lingers, fleeting and rare, in cosmic rays and thunderclouds, in particle labs and bursts of radioactive decay. It flickers into existence and vanishes again, like fireflies at the edge of a forest. You follow one now, in your mind's eye. A positron, perhaps, born in the upper atmosphere, when a high-energy cosmic ray meets the blanket of Earth's sky. It exists for the briefest moment, then collides with an electron and the two are gone, their mass singing into light. Tiny events, invisible events, and yet they are happening all the time, little whispers of antimatter dancing through our world. It is hard to imagine, perhaps, that something so powerful can also be so delicate. But that is the nature of this strange twin. Antimatter is not loud. It is not sinister. It is not evil, as some old science fiction stories like to pretend. It is simply opposite. You think of it like breath and silence, like a heartbeat and the pause in between. Neither is complete without the other. Matter alone is only half the song. If you could float deeper, you would see the beauty in the math symmetry, written into every equation. For every process, a reverse. For every particle, an antiparticle. It's called CPT symmetry, though you don't need to remember the name, just the idea that the universe is built with reflection in mind. Even the laws of physics seem to respect this. They allow you to reverse charge, flip parity, and turn back time, at least in theory, and the universe will still nod in agreement. This balance is not just academic. It is the root of some of the most ambitious dreams in science, because antimatter, in its rare and fleeting beauty, carries with it astonishing energy. When it meets matter, it transforms entirely into light, no ash, no residue. A perfect conversion, a dance of opposites that leaves only brightness behind. You lie still, letting the thoughts settle. Every time you blink, electrons move. Every time you breathe, atoms shift. And yet, their twins, their antimatter reflections are almost never seen. But they are real. They are made in laboratories, in particle accelerators, shaped like rings beneath the Earth. They are found in lightning storms. They are glimpsed in the data from deep space. They are not science fiction. They are part of the same story, your story, the story of what it means to exist. And if they are real, what else might be? The thought floats there, soft and inviting. Could we use antimatter, not just to understand the universe, but to move through it? Could this delicate, invisible mirror become a form of fuel? Could a single gram of antimatter carry a ship beyond Mars, even beyond Pluto, riding the energy of annihilation into the stars? It's a lovely thought, a bedtime thought, something worth following. You let the question hover, like the antimatter particles themselves, brief, weightless, glowing. You do not need answers yet, only wonder. And as your body relaxes and your breath slows, the rhythm of the universe gently rocks you, matter on one side, antimatter on the other. A quiet symmetry, broken just enough to make you reel. But now that you've met antimatter, the question stirs again. How did this power, this light-born twin, first come into being? Let's drift closer to the beginning. Let's listen to the story of how light became fire. You begin again in stillness, eyes closed, breath steady, mind soft as dust in sunlight. The stars you met before have faded for now, leaving only the great velvet of space stretched out around you. But beyond this quiet, before even silence existed, something once stirred. There was no sound, no light, not yet, no time that ticked in order. Just a moment singular, radiant, when everything began. You drift toward it, not as a traveler, but as a listener. In the very beginning, the universe was not vast. It was not cold. It was not even space. It was dense, impossibly so, and hot beyond imagination. All that would ever be was wrapped tightly into a single spark of being. Not a star, not a flame, but a moment so full it had no choice but to unfold. And it did. Not with an explosion, as fireworks do, but with a blooming. The fabric of space stretched like warm dough, expanding from nothing into everything. Energy surged, not in flashes, but in waves. And from this energy came the first children of the cosmos, particles and antiparticles, matter and antimatter. You picture it like a dance, not of feet, but of forms. Pairs appearing side by side, spinning, separating, colliding. Each proton was born with an antiproton, each electron with a positron. Each partner perfectly matched, yet moving in opposite directions. Twins, opposite in charge, equal in mass. This was a universe in balance. For every note, a harmony. For every push, a pull. The air you breathe tonight is made of matter, and so you might feel a quiet kinship to the particles that stayed. But once, there was no preference. Matter and antimatter rose from energy in equal amounts as if the universe itself favored fairness. And yet, you know how this story unfolds. You are here, the walls around you, the pillow under your head, the thoughts in your chest all made of matter. But where did the antimatter go? That question echoes still through the halls of science. The mystery has a name, baryon asymmetry, but you don't need to remember it, just the shape of the puzzle it leaves behind. Somehow, something tipped the scales. Perhaps it was a tiny difference, tucked into the rules of physics. Perhaps one kind of decay slightly favored matter over antimatter. Perhaps the particles that emerged from the heat of the Big Bang weren't entirely symmetric. Or perhaps the universe, like a painter, made its first brushstroke imperfect on purpose, so that the cosmos could unfold in color. Whatever the cause, the result was delicate but dramatic. Imagine a sea of particles, billions upon billions of matter and antimatter meeting, touching, vanishing into light. Each collision a flare of pure energy, a silent sigh of transformation. The fire that lights galaxies comes from this vanishing. The light that fills the night sky has ancestors in those ancient pairs. But not all the matter vanished. For every billion pairs that annihilated a billion particles of matter and a billion of antimatter, one extra matter particle remained. Just one. Over and over. A tiny difference multiplied across an infinite universe. That sliver of survival became stars, and planets, and people, became breath, became you. And the rest? The antimatter? It was lost to light. Its story written in the photons that now glide through the cosmos, as the cosmic microwave background, a whisper of heat, a fossil glow. The sky still holds the memory of the dance it cannot replay. You might imagine the universe grieving its missing half, or perhaps it never saw a loss at all, only a transformation. Antimatter did not die. It became light, and in doing so, it painted the canvas for all that followed. In this moment, you are floating just behind that cosmic dawn. You feel the press of unimaginable heat, the bright emergence of being. And you feel the chill that follows as expansion cools the universe and makes it hospitable to form. Quarks settle into protons, protons into atoms, atoms into dust, dust into stars. The universe begins to breathe. And here, even in this breathing, the memory of matter's twin remains. Because antimatter didn't vanish entirely. Even now, it's born in rare places in lightning bolts that strike the upper atmosphere, in radioactive decay deep within the earth, in high-energy collisions crafted by human hands, in great underground rings. Every time you see a PET scan image in a hospital, a positron emission tomography scan, you are witnessing antimatter at work. A positron meets an electron, and their brief reunion gives off light that tells doctors where cancer may lie. Healing, born from annihilation. So, you see, antimatter is not gone. It is elusive, yes, fragile, but it is still with us, like a memory we cannot touch, yet which shapes us all the same. And perhaps this is the deeper comfort, the deeper lullaby, that what was once equal still sings in symmetry, that we are not made of winning, but of surviving. That the matter left behind carries in its structure the memory of its opposite. Even in our atoms, there is the whisper of what almost was. You rest in this thought. The universe began in light, not gentle at first, but fierce. And from that light came duality. Every something had its mirror. Every push, a pull. Every heartbeat, an echo. The fire of existence was not a blaze, but a balance. Tonight, you travel not just through space, but through balance, through the quiet places between particles, through the thin line where matter ends and light begins, through the gentle cradle of symmetry broken just enough to make a world. You imagine what it would be like to find that balance again, not in the distant past, but in the near future. Could we make antimatter again and keep it? Could we harness the same transformation that lit the early universe? Could we turn this energy into motion, this fire into fuel? Could light become motion once more? And if so, how? You rest now, still in the darkness between stars. Space hums like a distant lullaby. The memories of matter and antimatter still shimmer behind your eyes, their ancient dance not quite forgotten. And now, something new begins to stir, not a question, but a glow. You open your inner hands, and in them, you hold what cannot truly be held. A single particle of antimatter, or rather, a single pair, one particle of matter, one of antimatter, resting together like opposite notes on the same scale. They do not touch, not yet. They hover delicate, humming with tension. The tiniest shift, the gentlest nudge, and they will meet. And when they do, they will vanish. But not into nothing, into light. Imagine that, not a flicker, not a spark, but a pulse of energy more intense than fire, more focused than thunder, more perfect than any chemical burn. In that moment, something profound occurs. Complete transformation. All mass, all rest and substance, becomes motion, becomes light, becomes energy. This is where you meet the idea that floats through physics like a quiet ghost. E equals mc quadrad. You've heard it before on blackboards, in books, whispered in science shows. But tonight, you do not hear it as a formula. You feel it. E is energy, what moves, what flows, what warms and lights and pushes. M is mass, what sits still, what resists, what holds. And C, the speed of light, is not just speed, it is the edge of the possible, the speed of cause itself, the thread of time woven into space. Square it, and you have the conversion rate, the ratio by which matter can become energy. The equation says this: even a tiny amount of matter, if turned entirely into energy, gives off an enormous burst, because the speed of light squared is no small thing. It is 300 million meters per second. Squared a number so large, your breath slows just imagining it. So when matter meets antimatter, and both are completely converted into energy, the result is breathtaking. You picture a paperclip, ordinary, unnoticed. It weighs about a gram. If that single gram of matter were to meet its exact antimatter twin and annihilate completely, the resulting energy would match that of a nuclear bomb, not in radiation or fallout, but in sheer released power. But no explosion, in the way you expect. Not chaos, not flames, just a flash of light, a release of pure energy, silent, complete. You begin to see why antimatter is called the most concentrated energy source known to science. It is not fuel in the traditional sense. It is not something you burn. It is a transformation waiting to happen. It is the promise that mass is never still, only sleeping. And yet, for all this potential, it is ghostly, elusive, a whisper of power. You let your mind drift further into the analogy. You've seen fire. You've boiled water, burned wood, lit candles. In those processes, only a fraction of the matter becomes energy, just the bonds between atoms breaking. The atoms themselves stay behind as ash, as exhaust, as remains. Even in nuclear reactions, fission and fusion, only a small percentage of the mass is turned into energy. Powerful, yes, but still imperfect. Antimatter is different. There is no waste, no ash, no unburned core. Everything is given. When matter and antimatter touch, it is absolute. They leave nothing behind but photons, particles of light. It is, in a way, the cleanest form of energy imaginable. No pollution, no moving parts, no residue, just transformation. And yet, you hesitate, because nothing comes without a cost. To create antimatter is incredibly difficult. It cannot be mined or dug from deep rock. It does not lie in reservoirs. It must be made, crafted from pure energy, using enormous machines that push particles to near the speed of light, then slam them together in blinding flashes. In this way, antimatter is like light condensed backward into form, and only with great effort. And, when made, it cannot be stored in the ordinary way. Place it in a container made of matter, and it will vanish, colliding instantly with the atoms of the container, releasing its energy in a destructive flash. So scientists trap it in magnetic fields, invisible cages made of force, not substance. The particles hover, suspended like dust in a shaft of sunlight, waiting, flickering, fragile. And this makes antimatter feel even more ghost-like, powerful but fleeting, present but unreachable, like a dream of energy, glimpsed but not yet held. You imagine now a future spacecraft not powered by fire or fuel, but by annihilation, tiny doses of antimatter released into a magnetic chamber. There, they meet matter and vanish, producing energy with perfect efficiency. That energy becomes motion not by pushing against air, as rockets do now, but by heating gas, producing charged particles, or releasing bursts of radiation that propel the ship forward in silence. It would be unlike any engine you've known. It would not roar. It would hum gently, steadily pushing faster and faster, without friction, through the black. The fuel, though tiny, would be immense in effect. A few milligrams could take a probe to Jupiter. A few grams, if we ever make that much, might one day carry a crewed ship to the edge of the solar system. You rest in this idea, letting it settle over you like a quilt of possibility. It feels so close, and yet not quite real, because the ghost fuel, for now, remains beyond reach. We cannot yet make enough. We cannot yet hold what we make. We cannot yet keep it safe, or stable, or ready. The tools we need are still growing. The understanding is still blooming. But even so, the idea remains. It waits, just beyond the horizon, like the first stars once waited to be seen. And perhaps that's enough. Because every step toward antimatter, every particle captured, every positron counted, every collision mapped, teaches us something not just about energy, but about the nature of change. We learn that matter is not solid, not fixed. It is potential. It is stored light, waiting to be freed. And in that freedom lies movement. And in that movement lies journey. Your breath slows now, because you realize this chapter is not only about power, it is about patience, about listening to what the universe whispers in its quietest reactions, about seeing how something so tiny can hold so much. A particle, a pair, a moment, a future. And yet, before we can ride that future, before we can turn light into motion, we must learn how to hold a ghost. Which brings you to the next step. If antimatter is so powerful, so clean, so full of promise, why can't we make enough of it? And what strange machines have we built to try? You begin this chapter underground, not beneath your blanket, but far beneath the soil and stone of the earth, deeper still, beneath the sound of wind and water. Here, in long tunnels curled like sleeping snakes beneath mountains, you find the quiet hum of human curiosity at its most precise. This is where we make antimatter. Not with hammers, not with fire, not by accident, but with focus, with patience, with tools tuned to the rhythm of particles, tuned to the memory of the universe's first breath. You stand now, in the mind's eye, beside one of these great machines, the particle accelerator. It is a ring, a hollow circle many kilometers wide, though you see none of it directly. The structure is buried, hidden from view. What you feel is its pulse, like the beat of a mechanical heart. Inside this ring, particles travel at nearly the speed of light protons, mostly guided by magnetic fields that bend them like river currents. Around and around they go, until they meet their counterpart, head-on, in a moment of pure collision. And in that collision, energy becomes creation. Not just heat, not just noise, but particles, new particles, particles that flash into being and vanish again in less than the blink of a blink. Among them, antimatter. You don't see it with your eyes. You see it in traces, in spirals drawn in detectors, in decay paths captured, like the trails of stardust across photographic plates. A positron appears the mirror twin of the electron. An antiproton flickers heavy, opposite, gone in a whisper. And yet, we know they were there. You might think of it like lightning trapped in a bottle, only the bottle is magnetic, and the lightning is smaller than any storm. Scientists create these particles not to store them, but to understand them, to listen to their patterns, their preferences, their possibilities. But making antimatter is not simple. It takes energy, vast amounts. To produce even a single antiproton requires accelerating protons to extreme speeds and crashing them into metal targets. The collisions break open the fabric of mass, like striking flint until sparks appear. And for every billion protons smashed, only a few dozen antiprotons emerge. It is a yield so small you could count them by hand if only they'd stay long enough to be held. But they don't. Antimatter cannot touch matter. The moment it does, both vanish into energy. So we must cradle it gently, with fields that hold without touching. Penning antimatter inside magnetic bottles, traps that suspend particles midair like dancers frozen in motion. One of these traps is called a penning trap, a beautiful name, soft and round. You can imagine it like a glass orb suspended in darkness, lined with magnets. Inside it, a single antiproton floats, cushioned by forces, glowing in no visible way, but very much real. This is not science fiction. It is being done now by physicists at CERN and other labs around the world. Antihydrogen, the antimatter version of the simplest atom, has been made and held, briefly, in these traps. Not to power rockets, not yet, but to ask questions, to weigh, to compare. Does antimatter fall like matter does? Does it follow gravity's pull or push against it? Is it truly symmetric, or are there tiny differences waiting to be found? In these tunnels, we are not building fuel tanks. We are building understanding. And yet, a dream persists. What if we could make more? What if the same energy that creates antimatter could be drawn from stars or harvested from cosmic rays? What if antimatter could be captured from space itself, from the high-energy events that pepper the galaxy, from the edge of supernovae, from the breath of black holes? You think of satellites now, floating far above, equipped with magnetic nets, not catching fish, but catching fragments, lone positrons, drifting through space like seeds on the wind. The Alpha Magnetic Spectrometer, mounted on the International Space Station, already watches for such signs. It does not catch them, but it listens. And what it hears is quiet, but promising. Some believe we might one day scoop antimatter from the Van Allen belts, the zones of charged particles trapped by Earth's magnetic field. Antimatter born in cosmic collisions, circling above our heads. Rare. Invisible. But maybe collectible. You rest in this image. Nets made of magnetism, fishing for ghosts. But even if we could catch them, even if we had all the traps and all the tools, we still face the same silence. Antimatter must never touch. So the question becomes, can we scale up the bottle? Could we build containers large enough, stable enough, safe enough to store grams of antimatter? Could we shield the traps aboard spacecraft? Could we control the rate of reaction, feeding tiny amounts of antimatter into matter to release steady thrust? These are not questions of imagination alone. They are questions of engineering, of funding, of time. Because even now, all the antimatter humanity has ever made, every particle produced in every lab combined, would not weigh more than a feather. And the cost? Beyond measure. Billions of dollars for micrograms. A currency paid not in money, but in energy and complexity. But that has never stopped us before. Long ago we captured fire. Later we captured electrons. Now we chase shadows, particles that vanish the moment they touch the world. And though the chase is difficult, the reason remains simple. Antimatter may be rare, but it is real. And real things can be understood. They can be gathered, tamed, used. You breathe softly now, feeling the rhythm of patience. Science does not rush. It steps gently, like a gardener planting seeds in a field that may take generations to bloom. And so we build machines underground and listen to particles above the clouds. We trap what flickers and call it progress. We build knowledge the way trees build rings, one season at a time. Because if we ever hope to ride the wind of annihilation, we must first learn to hold a spark without burning. And perhaps, one day, we will. But even if we capture the ghost, how do we use it to move? What kind of engine could carry a ship not with fire, but with light born from vanishing? Now you are drifting in the quietest place imaginable. There is no wind here, no up, no down, no footsteps to follow, no sky to separate ground from possibility. Space surrounds you like velvet, soft, cold, endlessly deep. And in this stillness, your mind becomes the ship. You begin to wonder, how do we move here? On Earth, motion has a partner resistance. Every step pushes against something. Wheels turn against roads. Wings press against air. Boats part water. Fire, when trapped in an engine, pushes backward to move forward. But space has no air, no ground, no path. It offers no resistance and no help. There is only inertia, the rule that says, if you are still, you stay still. And if you are moving, you keep moving. So, how do you move a ship here? In the black? With no air to push and no ground to press against? You start with what you know. Traditional rockets. Giant, noisy towers that rise on pillars of flame. They burn fuel, chemical fuel, to push exhaust out the back. That backward push creates a forward thrust. You've seen it in launches. You've heard the roar. But rockets carry their own limits. They must bring all their fuel with them. And as they burn it, they grow lighter, but also slower to accelerate, because their fuel runs out fast. Chemical propulsion is like sprinting, loud, powerful, and brief. Now imagine something quieter. A ship without flame. A ship powered not by pushing against matter, but by transforming matter itself. This is where antimatter enters not as an idea, but as a means. When a particle of antimatter meets a particle of matter, the result is not exhaust, not fire, but light, pure energy, photons. And photons, though they have no mass, carry momentum. They can push, not hard, not fast, but surely. This push, known as radiation pressure, is soft but real. You can feel it not on your skin, but in equations in gentle motion added up over time. Imagine standing in a canoe in a still lake. If you throw a ball backward, the canoe glides forward. Now imagine throwing thousands of tiny, weightless beams of light instead of balls. That's what photons do. And in space, where nothing pushes back, even a whisper of force can move mountains if you have time. In an antimatter rocket, this transformation is at the heart of everything. There are different designs, different visions. Some imagine a system where antimatter meets matter in a controlled chamber. The resulting explosion of photons is directed either by mirrors, magnetic fields, or clever geometry, so that the light exits one side of the ship. That exit creates momentum. The ship moves. Other visions use the energy from annihilation to heat another material like hydrogen into plasma, which is then pushed through magnetic nozzles at high speeds. This is more like a hybrid, the raw energy of antimatter channeled into more familiar mechanics. But the most elegant idea is the pure photon drive. No moving parts, no burning, just particles transforming into light, and that light pushing the ship forward. It sounds poetic, doesn't it? To sail through space not with flame, but with annihilation, with light born from the disappearance of opposites. You begin to feel the rhythm of it, a ship gliding silently, each moment fed by the tiniest interaction, a meeting of matter and antimatter, a burst of light, a soft push, again and again. And because there's no friction in space, the push never has to be strong, it just has to be steady. Over days, weeks, months, that soft push builds speed, faster than any chemical rocket, faster than anything we've flown so far. In theory, such a ship could reach speeds approaching a significant fraction of the speed of light, perhaps 10%, perhaps more, if engineered carefully. At those speeds, Mars becomes a neighbor. The outer planets drift closer. The stars, still distant, begin to feel not impossible, but inevitable. And all without fire. But it is not without cost. To guide antimatter, into matter in precise amounts, at exact moments, requires immense control. The containment fields must be flawless. The timing must be perfect. The chamber must withstand incredible energy release without failure. And all of this must happen in the vacuum of space, where help is always far away. This is not just engineering. It is choreography, a dance of particles at the edge of physics and patience. Still, the reward is unlike anything we've ever dreamed. To move through space without flame is not just a technical shift. It is a change in rhythm, a new relationship with motion, with time. Because when you move without resistance, motion becomes meditation. There is no shake, no rumble, just direction. Velocity becomes a choice, not a struggle. You coast, you drift, you glide. You feel it now, your body slowing into sleep, your thoughts coasting gently into stillness. The ship you imagine moves the same way, quiet, precise, effortless, not because the work is easy, but because it's done with elegance. There are no fumes, no smoke, no shaking walls, only the invisible gift of transformation, mass into energy, energy into momentum, momentum into journey. And somewhere, on the edge of vision, you see the next step. Because if we can move this way without fire, without fuel tanks as we know them, then we are no longer limited by old designs. We are no longer throwing ourselves into the sky and hoping to land. We are sailing. But now, another question drifts in like stardust. If we build such a ship, can we build it big enough? And even if we do, can we carry the ghost fuel safely? You wake gently, still floating in thought. The ship without fire still glides in your imagination, tracing curves through the dark. But now, another feeling settles in. A weight, not heavy in your chest, but real, the weight of limits. Because while dreams lift you, reality reminds you where your feet still touch. And this, too, is part of the story. Antimatter. You know now what it is opposite. Powerful, elegant. You know how it vanishes into light. How a single gram could carry a probe to the outer planets. You've felt that promise. You've ridden it through space. In thought, if not in practice. But now, you return to Earth. Not as a fall, but as a grounding. Because power, in science, is never enough. You must also hold it. And holding antimatter is the heart of the problem. You walk now, not in space, but through a laboratory, a real place, lined with wires and cooled steel. Everything here is built with precision. No noise, no excess. Every piece of equipment wears its purpose like a second skin. In the center of the room is something delicate, a magnetic trap. You remember it from before the penning trap, a device that holds charged particles not with walls, but with invisible fields. Here, scientists keep antiprotons for fractions of seconds, sometimes longer, enough to study, enough to measure, but not enough to fuel a ship. Because this trap, intricate and miraculous as it is, can hold only a few particles, a whisper of a whisper, and to travel to Mars, you would need trillions. You would need to hold them, transport them, and release them without ever letting them touch the walls. Think of it like catching lightning not once, but endlessly, and never letting it spark. That's the problem. Antimatter cannot be touched. The moment it meets matter, it disappears. Not like smoke, not like mist, but like memory fading into light. And so, to store it, you must build containers that are not really containers. You must build force fields, magnetic cages that wrap around the particles without ever touching them. And these fields must be perfect. The slightest instability, a power flicker, a magnetic wobble, a cosmic ray at the wrong time, and the antimatter is gone. Worse, it releases its energy. It explodes. Not with shrapnel, but with radiation. A single mistake could destroy the trap, the ship, the lab, the plan. So scientists proceed slowly, carefully. They build backups for backups. They test with electrons, with protons, with simulations. They learn not just how to trap antimatter, but how to listen to it, how to feel its presence in the dance of sensors and signals. And even then, they are working with micrograms. To make more is another mountain. Creating antimatter requires energy, vast amounts of it. Right now, to make a single antiproton takes millions of protons and a particle collider longer than a train. And when it is made, it must be slowed, cooled, and trapped. This process, beautiful though it is slow, expensive, and fragile. You might picture it like trying to fill a cup with morning dew. The droplets are real. They are there, but they are hard to catch, and harder still to carry. Still, scientists do it. At CERN, in Europe, a facility called the Antiproton Decelerator slows these particles down, prepares them for study. Antihydrogen, a combination of an antiproton and a positron, has been created and held for a moment, not for fuel, not yet, but for understanding. And that's where we are now, in the phase of science where learning is more important than using, where questions matter more than launches. You feel that truth as you walk the imaginary corridors. This is not failure. This is patience. The long, slow breath before something changes. And while storing antimatter is a great challenge, it is not the only one. Containing it in space presents new layers: cosmic radiation, temperature fluctuations, vibrations from onboard systems. Even the act of moving, of accelerating, can disrupt the fragile balance of magnetic fields. Cooling is another issue. Many storage systems rely on cryogenics, keeping components near absolute zero to reduce particle motion. This requires energy, infrastructure, stability, all difficult in deep space, where heat lingers forever and cold cuts to the bone. Then there's shielding, not from the antimatter itself, but from what might disturb it. Space is full of radiation-charged particles from the sun, from stars, from the very fabric of the cosmos. These particles can strike with force, changing the behavior of fields, triggering annihilation by accident. So the ship of your dreams, the elegant vessel gliding without fire, must also be a fortress, a quiet one, a strong one, with walls made not of steel, but of silence and balance. And still, the hope remains. Because every step forward brings clarity. The better we understand how antimatter behaves, the more we can imagine how to store it. And with that understanding comes innovation. Ideas are blooming like magnetic rings built into spacecraft hulls, or hybrid systems that use smaller amounts of antimatter to trigger reactions in more familiar fuels. Some designs use antimatter as a catalyst, not as a main ingredient, just enough to spark something larger. These paths are not as pure as the photon drive, but they are more achievable, more grounded, and perhaps that is the way forward. You pause here, in the quiet of thought. It is okay to want the stars, and it is okay to take the long road. Because every great journey begins with difficulty. Fire was once hard to hold. Electricity was once a curiosity. Now, they light our homes. Now, they power our voices, carry our thoughts across oceans. So perhaps, one day, antimatter will do the same. Not as fiction, not as magic, but as part of the rhythm of progress. You rest again in that idea. That difficulty is not a door that won't open, it's a lock waiting for the right key. And somewhere, quietly, the key is being made. But until then, maybe we should look higher. Because while making antimatter on Earth is hard, the universe itself makes it all the time. You are no longer on Earth. Not underground in a lab, not walking through steel corridors of cooled machines, but far above, past the clouds, past the drag of atmosphere, drifting where day and night circle endlessly. Space stretches out around you, vast and softly lit. The silence here is deep, but not empty, and within this quiet particles move, racing, bouncing, vanishing. Some of them belong to a mystery you've come to know, antimatter. It is easy to think of antimatter as rare. On Earth it is. We build great machines to create even a single particle. But out here, far from the ground, nature is generous in her own subtle way. The cosmos, after all, has been making antimatter since the beginning. You begin to drift alongside the edge of Earth's magnetic field. It's not visible, but it's there wrapping the planet in invisible arms, holding back the harsh winds of space. Solar particles, cosmic rays, and high-energy collisions all play along its edges. And in these collisions, antimatter is born. Not in great clouds, but in flickers, in flashes. A positron here, an antiproton there. Born of motion and force, they dance for a moment, then vanish when they meet their opposite. But for a brief time, they are free, and it's in that sliver of existence that we see a possibility. You now hover near a satellite, not an imaginary one, a real machine, currently orbiting high above Earth, the Alpha Magnetic Spectrometer, or AMS-2. It floats aboard the International Space Station, scanning the sky for particles, watching the shadows of physics move through its sensors. Its job is not to trap antimatter, but to listen for it. It measures positrons, those tiny anti-electrons, and tries to trace their origins. Are they born in thunderstorms? In cosmic collisions? Or do they hint at something even deeper like the decay of dark matter? But the key is this. The AMS has seen them. Positrons, antiprotons, drifting through space, real and measurable. Nature is creating antimatter, and we are watching. So the next question becomes, can we catch it? You imagine a net, not of strings or wires, but of magnetic fields, a vast collector spread wide in orbit, tuned to the dance of charged particles. It doesn't touch the particles. It guides them, like invisible fingers steering sparks into a jar. Such a device would need precision. It would need shielding. It would need stability. But in theory, it's possible. Charged antimatter particles can be trapped using magnetic fields. We already do this in labs. In space, there is less interference, less atmosphere, less noise. You begin to dream, softly, of orbiting fuel stations. Satellites that drift through radiation belts, catching positrons one by one, scooping them from Earth's own magnetosphere, where particles spin in loops. Perhaps one day, such stations could gather enough to refill a small reserve, a slow, silent harvest of cosmic energy. This is not mining, as we know it. There is no digging, no churning of soil. It is more like fishing, casting nets into invisible tides, waiting patiently for particles to swim in. In fact, scientists have already begun thinking this way. Theoretical missions have been proposed like NASA's positron trap, designed to float in low Earth orbit and gather antimatter from the Van Allen belts. These belts, filled with charged particles trapped by Earth's magnetic field, contain trace amounts of positrons born from cosmic rays, striking the upper atmosphere. The flux is small, the yield is low, but it is there. In time, we may learn to collect enough for research, for medicine, for propulsion. And beyond Earth, other sources wait. Jupiter, for example, has a massive magnetic field more than 10 times stronger than Earth's. Its radiation belts are fierce, filled with high-energy particles. Some believe its environment could be rich in trapped antimatter, waiting in loops of magnetic orbit. A probe sent to Jupiter could serve as a deep space fuel station gathering antimatter from the giant planet's storms, refueling before moving outward. Far-fetched? Maybe, but not impossible. The physics is sound. The engineering simply needs time. You now imagine ships pausing in orbit, not to refuel with liquid or gas, but to gather positrons stored in traps. A slow process, yes, but in space, time stretches differently. Patience is part of the design, and there's beauty in that. In building systems that rely not on force, but on waiting, on letting the universe offer its gifts in its own rhythm. Still, challenges remain. Antimatter is delicate. Once gathered, it must be stored, as you've already seen, in magnetic fields, kept from contact with matter. The more you gather, the more fragile the system becomes. And the quantity available is small. Trillions of particles may sound like a lot, but in terms of mass, it's minuscule. To power even a small probe, You would need to gather for months, maybe years. But space gives us that. Time, silence, the gentle unfolding of long effort. In this way, gathering antimatter in orbit becomes less about speed and more about scale. If we can't make enough on Earth, perhaps we gather a little at a time, not from one source, but from many. Earth's belts, Jupiter's fields, cosmic rays in interplanetary space. And maybe one day, artificial structures, swarms of collectors surrounding a planet, or arrays deployed like sails to drift through streams of particles, always watching, always catching. This is not fantasy. This is slow science, long design, a vision that lives on the edge of now. And you feel yourself drifting again, through that vision, floating from collector to collector, as if in a calm garden of magnets and charge. The stars do not rush, neither should we. We are not building gas stations. We are building symphonies, patient structures, tuned to the whispers of the universe. And somewhere in that whisper is a promise. If the cosmos gives us antimatter, even a little, then it invites us to use it, carefully, lovingly, as a companion, not a tool. You begin to rest now, held in that possibility. We may never mine mountains of antimatter, but we may gather it, slowly, gently, like catching dew in the morning air. And with that, a new question rises. If we could gather enough, what kind of journey might we take? Close your eyes. You are in a ship that does not roar. It does not tremble. There are no plumes of fire, no rattling frames, no countdowns echoing through concrete chambers. There is only stillness, and then motion. Motion that arrives like a thought, smooth, silent, certain. You're gliding away from Earth now, not with chemical force, but with annihilation's whisper. Behind you, matter and antimatter meet in perfect balance. They touch and vanish, leaving behind not destruction, but light. Photons, particles with no mass, but real momentum, the push of possibility. This is antimatter propulsion. You don't feel a jolt. You don't feel weight pressed into your chest. Instead, you feel release. The ship accelerates gently, continuously, like falling without end except here. The fall is forward, and the gravity comes not from a planet, but from precision. You look ahead, and Mars waits. Its rust-colored plains shimmer faintly in your thoughts, bathed in sunlight that hasn't yet warmed your vessel. The distance that once seemed immense, over 50 million kilometers, is now simply ahead. How far becomes less important than how fast. In a traditional spacecraft, you would spend months getting there. Launch windows, gravity assists, fuel weight all shape the journey. You would coast through space in long, arcing curves, shaped not by desire, but by physics. But now, with antimatter guiding your way, the rules bend slightly. You have a new kind of engine, one that doesn't lose energy as it climbs out of gravity's grip, one that doesn't rely on great tanks of fuel, growing lighter with every thrust. Antimatter allows you to burn at a steady pace, slow but unrelenting. In theory, you could reach Mars not in 9 months, but in 30 days, even less, with enough fuel. A trip measured not in seasons, but in breaths. And not just Mars. Imagine continuing onward. Jupiter next, its storm-wrapped clouds and striped atmosphere looming like a giant's gaze. Then Saturn, silent and golden with rings. Each destination, once a dream, becomes reachable not through magical speed, but by persistent push. This is the gift of constant acceleration. Every second, your ship moves faster, not dangerously, but rhythmically, a soft hum of movement that builds, like the tide, into true momentum. Halfway through your journey, you flip the ship and begin to slow, using that same push in reverse. You never need to slam on brakes or burn more fuel than you planned. Just turn and let the same engine that carried you out bring you gently in. You begin to feel what travel might mean when time itself shifts beneath you. Because as speed grows, strange things begin to happen. Time, that ever-constant beat of experience, begins to stretch. For others watching from Earth, the minutes pass at their regular pace. But for you, inside the ship, they feel slightly longer. At higher speeds, approaching a fraction of light's velocity, this stretch becomes profound. It's called time dilation, and it means that your clock ticks slower, gently, compared to those back home. You don't notice it at first. But over vast distances, over long voyages, the difference adds up. You return home having aged less, not by magic, but by motion. And so, antimatter propulsion not only shortens distances, it reshapes time. It asks questions, softly, about the human experience. What is a journey when space shrinks and time bends? What does it mean to be a traveler when the landscape blurs beneath your feet? This ship you ride, let's imagine it more clearly now. Its frame is not bulky, but elegant, streamlined, not for aerodynamics, but for efficiency. It houses storage fields, magnetic traps, to contain the antimatter, layers of shielding to protect against radiation, thermal systems to cool its engines and instruments. There is no roaring furnace, no exhaust pipes, only chambers where particles meet and vanish, their absence transformed into energy, then motion. This process, though small, is mighty. A gram of antimatter can power your entire voyage. Just a gram. The weight of a paperclip. The mass of a hummingbird's heart. And with it, you cross the solar system. You wonder what it would feel like to be inside that ship for real, not just in mind, but in body. Would you sleep to pass the time? Would you spend the journey in reflection, staring at the stars as they shift slowly outside your window? Or would you work monitor systems, write messages, plant your mind in new ideas, blooming like orchids in the dark? Would loneliness arrive, or would the stars become enough? Because the journey, though shorter than before, is still long enough for silence, long enough to know the shape of yourself, unshaped by crowds or clocks. You might grow closer to your thoughts, to your own breath. You might find beauty in the whisper of a reactor, humming with the rhythm of annihilation and thrust. And perhaps you wouldn't be alone at all. Not with a crew, perhaps, but with a purpose. Antimatter travel isn't just about reaching planets faster. It's about reshaping our relationship with distance, with possibility, with what we think the universe will let us do. Right now, our limits are measured in years. A robotic mission to the outer planets takes decades. A probe to the stars? A century or more. But with enough antimatter and enough patience, we might reduce that from centuries to decades, from decades to years, from dreams to timelines. You feel that as you drift the shift from imagination to blueprint. Not science fiction, just science waiting. Of course, there are challenges. We've spoken of them before. The traps, the containment, the cost. But this chapter is not for limits. It is for vision. And so you drift, again, toward what could be. Imagine ships leaving Earth not in desperation, but in exploration. Not as escape, but as expansion. Quiet vessels powered not by flame, but by disappearance, by particles meeting their twins and vanishing into motion. They do not pollute. They do not roar. They do not need to carry vast reserves of fuel, only precision and the will to wait. They are slow to start, but once begun, they become unstoppable. And what of the future? Beyond Mars? Beyond Saturn? Could we travel to the nearest stars? At 10% the speed of light, a journey to Proxima Centauri, our nearest stellar neighbor, would take 40 years. Not fast, by impulse, but fast enough that a child could leave and return as an elder. Fast enough to carry messages between stars, not myths. Fast enough to be worth dreaming for. But such speed comes with questions. How fast is too fast for the human soul, for our minds, our bodies, our sense of place? Will we be ready to change so much, so quickly? These are not answers we must rush. They are seeds we plant. The voyage is not just across distance, it is across understanding, and you are already halfway there. Let that thought settle, soft as dust on a windowsill. And as you begin to drift again, let one final image carry you onward. A single particle, a positron, tiny, silent, born of energy, eager to vanish. And yet, when met with purpose, it can push a ship between worlds. A journey made possible by a moment. But to make that moment real, we must first ask, can the human body bear such speed? And can the human heart bear the solitude that follows? Your breath is gentle now, slow and sure. It follows a rhythm, one you never chose but have always known, the rhythm of Earth, the rotation of days, the weight of gravity, the filtered sky, the sun-warming skin, the air pressing evenly against your lungs. You were made in this cradle. Every part of you, from your bones to your blood, your heartbeat to your hunger, is a response to this one spinning planet. You are, in every way, tuned to its song. But now, you are leaving. The antimatter ship has set course, gliding forward through vacuum, its engine quiet and steady, its thrust constant, no jolts, no roaring stages. But as your speed builds and the journey stretches, your body begins to notice what your mind first imagined. You are no longer where you were made. And the question rises softly but insistently. Can you survive this speed? Not just the velocity, but the change, the distance, the silence, the deep reshaping of everything your biology once trusted. Let us begin with acceleration. Though the antimatter engine pushes you gently, the effects accumulate. In a constant thrust ship, artificial gravity becomes possible. Not from spinning, as some designs suggest, but from continuous motion. Accelerate in one direction, and the floor beneath you begins to press upward, as if gravity itself were rising to meet you. This is good. Your bones welcome it. Your muscles hum in gratitude. Prolonged weightlessness in space leads to atrophy, loss of bone density, weakness. But with steady acceleration, you mimic Earth's embrace. Your body believes, once again, that it is home. Still, there are limits. The human body can tolerate acceleration, but only up to a point. Fighters and astronauts train for G-forces, the sensation of weight pressing harder and harder. But on an antimatter ship, the goal isn't to push the body to its limit. It is to cradle it gently, with 1 G of steady thrust, like Earth's pull, maintaining balance. And then, there is radiation. Beyond the shield of Earth's magnetic field, the universe becomes a different kind of ocean, one made of particles, not waves. High-energy cosmic rays and solar flares stream through the blackness, quiet but potent. They pass through the skin, through walls, through silence itself. On long voyages, this radiation is not an inconvenience, it is a hazard. Exposure accumulates, damaging cells, increasing cancer risk, weakening immunity. The ship must be wrapped in shielding. Not armor, but layers of thought water tanks, magnetic deflectors, perhaps even electromagnetic fields, designed to bend the rays away. You lie inside this protection, like a child in a crib built of starlight and care. Still, some rays will slip through. No shield is perfect. But you adapt. Your body repairs. Medicine travels with you. Perhaps one day, your DNA itself will be edited to resist radiation better, a nod to CRISPR and the quiet miracles of gene science. Then comes isolation. You are far from Earth now, not just in kilometers, but in connection. Radio signals take minutes to travel. Messages echo like voices across canyons. Real-time conversation fades into memory. The crew, if there is one, becomes your village. If you are alone, your mind becomes your companion. What happens to the human soul when there are no cities, no forests, no clouds? When every sight outside your window is stars and silence? When days no longer begin or end? Here, you need something more than air and food. You need meaning. Astronauts often speak of the overview effect, a profound sense of unity and awe when they see Earth from orbit. On longer journeys, that effect deepens. You begin to feel not just awe, but transformation. You are not merely traveling through space, you are becoming part of it. Still, the brain seeks rhythm. Sleep cycles drift without day and night. Circadian rhythms must be regulated by artificial lights, routines, music, memory. You live inside a ship, but also inside your mind, and both need balance. So you build a new kind of Earth. You decorate your space. You plant small seeds, basil, maybe. You keep time, not with clocks, but with rituals. Tea at sunset, even if the sun is just a memory. Journaling, exercise. Messages to Earth. Songs from childhood. These are not luxuries. They are lifelines. Because the human element isn't a problem to solve. It is the purpose of the voyage, the reason for the ship, the soul behind the spark. And so we ask, not just can we survive, but how do we survive well? We rethink health, not just as survival, but as thriving. We bring psychology into engineering. We design habitats that mimic Earth not in detail, but in rhythm. Soft lighting, curved walls, soundscapes that breathe. Even food becomes a kind of therapy, not just calories, but comfort. Warm meals, familiar textures, shared moments around a table. Even if the gravity is artificial, you realize that space does not take your humanity. It invites you to reshape it. And with reshaping comes evolution. Not in the Darwinian sense, slow and generational, but in how we train, prepare, and protect. Astronauts of the future may undergo biological modifications, enhanced immunity, better radiation shielding at the cellular level, muscles trained to work in shifting gravity. Some may choose neural implants to monitor health. Others may rely on AI companions, not just machines, but presence, voices that learn your moods, that respond with empathy, that remind you, gently, that you are never truly alone. This is no longer science fiction. It is a new kind of anthropology. You are no longer a creature of one planet. You are becoming multiplanetary, perhaps even interstellar. And to do that, you do not abandon who you were. You expand. You become more. Still, challenges remain. Pregnancy, for instance. Can new life begin in space? How does microgravity affect development? What happens to growing bones, to forming organs, under artificial light and synthetic day? These questions linger, tender and unresolved. But you are not afraid of them. You welcome them as part of the long unfolding. Not everything must be known at once. Some truths are slow, like the journey. Because to follow the antimatter path is not just to build ships, it is to build people who can ride them, who can endure the speed, the silence, the distance, not as punishment, but as a new kind of poetry. And you are almost ready. You've seen the engine, you've imagined the trip, you've felt the strain, the stretch, the solitude, and still, something in you says yes. You would go, not to escape, but to explore, not to conquer, but to witness, not to leave Earth behind, but to carry it with you in breath, in memory, in every cell of your being. You are not built for stasis, you are built for motion. And now, you begin to wonder something more. If we can travel this far, who gets to decide where we go next? And who gets to come? You drift now in stillness, not because the ship has stopped, but because the questions have begun. You've seen how antimatter works, the beauty of opposites vanishing into energy. You've imagined the vessels it might propel. You've felt the shift in time and the stretch in the soul. You've faced radiation, acceleration, and solitude. You've walked the long corridors of what it might take to become more than earthbound. And now, another horizon appears, one not made of planets or stars, but of choices. Because even the quietest technologies carry voices. They speak of direction, intention, permission. Antimatter may be small, invisible, even, but its implications ripple through culture, governance, and justice. You ask yourself now, as your fingers trail the edge of possibility, who gets to go? And even before that, who decides? Antimatter, like any powerful resource, does not appear equally across the world. It does not arrive in baskets on doorsteps. It must be created, curated, captured with knowledge, with machinery, with patience, and those things live, for now, in only a few hands. So the first question becomes one of access. Will antimatter be shared, sold, patented? Will it be used as a scientific commons or as a currency? Will the countries and companies who create it decide who rides the ships and why? Already, the laboratories that make antimatter are precious and few. Particle accelerators humming beneath mountains, funded by governments, protected by policies. Their discoveries ripple outward, but not always equally. So you wonder, when the first antimatter-powered craft is built, who will sit inside? Will it be the scientist who dreamed the engine, the technician who refined the trap, the investor who backed the project, a politician, a pilot, or none of them? And what of the rest, the many who watch from the ground, who will never float, never accelerate, never look back at Earth from the darkness and whisper, "I am in motion"? Is antimatter travel something we all dream of, but only a few will touch? These questions are not new. They echo those of every frontier. Who owned the first seas? Who claimed the first skies? Who chose which voices were heard in the language of exploration? But this time, the distances are greater, the consequences deeper. You imagine a ship being prepared, antimatter stored, destinations set, and a list of who gets to board. Will it be fair? Or will it be familiar? Powerful technologies often promise a better future, but for whom? The propulsion may be revolutionary, but if it moves only the same few toward opportunity, what changes? You drift through these thoughts like clouds. You don't need to land on any one of them yet. Let them float. Let's ask another question. Who owns the antimatter that comes from space? If we build satellites to catch positrons in orbit, do they belong to the nation that built them? To humanity as a whole? To the company that designed the magnets? And what about Jupiter's belts, or cosmic rays, or antimatter gathered from distant systems? The Outer Space Treaty of 1967 old, but still spoken of, says, no celestial body can be owned by a nation. But does it speak for antimatter, floating freely? What of resources not taken from land, but from the air of the void? Already, nations discuss mining asteroids. Claims are made, laws are proposed, rights are imagined, before the dust has even been touched. And so we ask again, can ownership extend into the invisible? Can it reach into things born from physics itself? Or is antimatter different not because it is rare, but because it is born of balance? Because to use it, one must touch annihilation. You pause here. Because this is the heart of the matter. Antimatter doesn't just carry energy, it carries metaphor. It asks us to consider what it means to vanish, what it means to take opposites, matter and antimatter, and let them meet and disappear and become something else. Perhaps that is what we must do with power itself. Let the old oppositions, wealth and poverty, access and denial, one and many meet. Let them transform. Let them release something new. A propulsion of equity. A spark of inclusion. A moment of trust. You breathe in that vision. A world where the antimatter path is not only a technical one, but a collective one. Where the ships we build are not just fast but fair. Where decisions are made slowly, with care, with all voices heard. Where the future is not raced toward, but walked into side by side. It is not easy. No system begins perfect, and perfection is not the goal. The goal is motion with meaning, progress with purpose, flight with feeling. And so, you ask again, who gets to go? And you answer not with names, but with values. Those who carry wonder, those who ask questions, those who think not only of arrival, but of journey, those who know that space is not an escape, but a return to humility, to awe, to shared story. Perhaps those are the ones we should send. Not the boldest, Not the richest, but the most curious, the most compassionate, the most willing to represent not just themselves, but all of us. You close your eyes and imagine their faces. A poet, a farmer, a nurse, a child, an elder, not as passengers but as threads in the tapestry of what comes next. Because space does not belong to the powerful, it belongs to the quiet, to the careful, to the dreamers who speak in whispers and build not just engines but ethics. And now, as the chapter softens, you feel that whisper again, the one that carried you from particle to propulsion, from energy to empathy. It says, "We are not just building rockets. We are building the kind of people who use them wisely." And if that is true, then what kind of dream will we carry next? You are far now, so far from where you began. Not just in kilometers or concepts, but in thought, stretched gently across the arc of space and time. You've followed particles into collision, watched engines ignite from silent annihilation, floated between planets on beams of light. And now you rest. Not because the story is over, but because stories, like particles, often vanish into something else, something softer, something brighter. You imagine yourself curled near the edge of the Milky Way, your ship hovering in the darkness, no longer needing to move. The stars are close and far all at once. They look back at you, not with urgency, but with invitation. This is where science becomes story, where equations become comfort. Antimatter, the ghost fuel, the mirrored twin, may not yet power our ships, but it has powered something else. Imagination, the spark of curiosity, the long gaze upward. You think of that first moment, in a lab or a textbook, where someone whispered the word antimatter, and it lodged itself in your mind, not as danger, not as fiction, but as a door to something vast, hidden, possible. You step through, slowly, carefully, and this is where it led you. To the memory of symmetry, to the dance of creation, to the puzzle of survival, and the ethics of propulsion. And now to this, the quiet reflection, the knowing that wonder itself is a kind of travel. Outside your ship or your dream or your breath, the universe flows. Not with fire, but with patterns. Galaxies spiral. Particles blink in and out. Fields hum beneath what we can see. And floating among them, tiny and tender, is the idea of antimatter, not only as fuel, but as metaphor. A reminder that for every push, there is a pull. For every flame, a shadow. For every question, a quiet. You begin to sense the particle stream not with your skin, but with awareness. Imagine it, a steady tide of positrons and electrons, protons and antiprotons, drifting through the cosmos. Some born in supernovas, some in collisions of galaxies, some perhaps as echoes from the very beginning. Most vanish before we ever know they were here. But a few leave signs. A spiral in a detector, a flicker in the sky, a message from space that says, "I was real, I touched, and I transformed." This, you realize, is what antimatter teaches, not just how to move, but how to listen. The universe is not shouting, it is whispering. And those whispers are made of particles. You think of the alpha magnetic spectrometer, still circling Earth, catching hints of antimatter born in space. It listens every second, watches with patience, hopes. You think of the engineers sketching the first containment fields, traps made of silence and force. You think of the philosophers asking who belongs aboard the ship. You think of the children, somewhere, staring up at the sky, hearing the word antimatter for the first time and wondering, what if? That what if is the stream you now drift in. A stream not of water or light, but of attention. You are part of it. Every question you carried, every image you held, the photon drive, the positron trap, the garden of orbiting collectors, it flows here. You are not alone. Others float with you, though you do not see them. Thinkers, dreamers, engineers, poets, some with lab coats, some with notebooks, all caught in the gravity of a shared dream. A future where the universe is not unreachable, where stars are not distant, where motion is not noise, but music. The ship hums, not from engines, but from presence, from being part of a larger pattern. You exhale, slow, feel the rhythm of your breath. That, too, is a kind of propulsion. And as your body stills, your mind stays awake not with urgency, but with awareness. You do not need to arrive tonight. Antimatter will wait. The future, too, is patient. And if this journey has taught you anything, it is that even the most fleeting things, particles, thoughts, dreams, can shape everything. You let go now, not of the knowledge, but of the need to grasp it tightly. You release the questions into the stream, knowing that others will pick them up. Knowing that the next step, the next equation, the next trap, the next voyage is already forming somewhere. In another lab, another mind, another dream. And as you drift, you carry with you only this: a sense of wonder, a rhythm slower than speed, and the quiet understanding that every beginning is also a continuation. You followed antimatter through physics, propulsion, ethics, and awe. And now, you simply float, wrapped in the knowing that science, at its heart, is a kind of lullaby, one that never ends. And in the stillness of your final thought, you feel it again. That delicate, powerful truth. A single particle can change everything.